So now let's do a practice problem for t-interval, and specifically t-interval with sample statistics. A hospital is trying to cut down on emergency room wait times. It is interested in the amount of time patients must wait before being called back to be examined. An investigation committee randomly selects 85 patients. The sample mean was 2.5 hours with a sample standard deviation of 0.75 hours. Construct a 99% confidence interval for the population mean time spent waiting. All right, so we're given a lot of information in this problem, and we don't have sample data. So since we don't have the sample data, we're going to use sample statistics. So the first question is, what is the sample standard deviation? And I can see right here, and I'm going to highlight it in yellow, the sample standard deviation is 0.75 hours. It wants to know the sample mean. And again, here's the sample mean. I'm going to highlight everything so we know. Sample mean is 2.5 hours. Then it wants to know the sample size. Here, the sample size is 85 patients. So I'm going to put 85 patients here. It wants to know what's the confidence level or interval. And it shows right here that I need to do a 99% confidence interval. So I'm going to put 99%. And then it wants to know what is the lower bound and what is the upper bound. Well, that's where I need to go to mini tab. So again, I have my sample standard deviation of 0.7 hours. And then I have my sample mean of 2.5 hours. And then I have my sample my sample of 85 patients and my confidence level of 99%. I have everything I need. So now I'm going to go to mini tab, and then I'm going to go to stats, basic statistics, and one sample t. And again, I'm using a t interval because I don't have the population standard deviation. It was not given to me at all in that question. So now I'm going to change it from one or more samples, and I'm going to put summarized data. Sample size was 85. Sample mean was 2.5, and sample standard deviation was 0.75. I'm not going to click the box of perform hypothesis test, and instead I'm going to go to options. And here I'm going to change it from 95 to 99. And I'm going to keep the mean does not equal the hypothesized mean. Because again, with a confidence interval, it's basically I'm running a type of two-tailed test. So I hit OK, and I hit OK. So it gives me all the information I need. So what I'm going to do right now is I'm going to copy it and put it back in my document. So I'll have it here to answer my question. Nope, it didn't copy. Let's do this. I'm going to go back. Let's do this. I'm going to copy, and then hopefully now it'll work. So now I have everything I need, okay? So again, I'm going to go, what's my lower bound? My lower bound is right here. And I'm going to make it bigger so people can see it because it's kind of small. Okay, so my lower bound is 2.2856, and then my upper bound is here. And again, remember, your lower bound has to be a number lower than your upper bound has to be a number higher than your lower bound. Your lower bound needs to be a lower number than your upper bound. So from here, then, I want to make sure, and I want to get my error bound margin. Remember, there's two ways I can do this. So the first way is I can take my sample mean and subtract it from my lower bound. And if I do this, I'm going to use my calculator to do this. And if I put it in my calculator, I get 0.2144. Or again, remember, I could do, or I could 2.7144 minus 2.500 equals 0.2144. So there again, I have the same error bound margin. There's two different ways I could do it. So again, you see these numbers are the same. And you might be doing problems and they might be slightly off, and that's okay. Just put your you can pick the select answer or put one or the other, and we'll give you credit, because even though the decimals are slightly off, they're looking for the same thing. So let's go back and close the loop on what we're doing. So they wanted to know what construct a 99% confidence interval for the population mean time spent waiting. So I am 99% confident the population mean waiting time will fall between 2.2856 hours and 2.7144 hours, with an error bound margin of 0.214 hours. Okay, so I just answered my question. So that's what's going to happen. So really what they said is the sample mean was 2.5 hours, but they wanted to be pretty precise so they could give somebody an estimate of what it would be to wait in the emergency room. And you see that now a lot of hospitals are advertising their wait times so that people don't feel like they're going to spend hours and hours there. So based on what this committee found, they found that the mean waiting time is 2.2856 and 2.7144. And that kind of means that 99% of the time, this is what your wait will be. It will fall between these lower bound and upper bound.